Hello, geometry students. I hope you are having an awesome day. I'm so proud of you for getting into the swing of things in class and turning in your homework and attending your Zoom meetings and making the best of a challenging situation. Today, we're going to do our second part of the 5.1 notes. So we're going to do 5.1b, and the title is still Angles of Triangles. So our last lesson, 5.1a, discussed the types of triangles we can have, how we can classify them by their angles or their sides. This lesson is going to talk about other very important facts about triangles that we're going to use throughout the rest of the school year. So I'm super glad that you are here taking notes. So I am going to have you write down 4 different theorems and then show a picture for each of them. I don't expect you to write the words for the theorem. They are in the book online if you would like them, but I think that's just a little bit too much writing for the notes. So I'm going to have you just write down the theorem name and the picture that goes with it. So the first theorem is called the triangle sum theorem. Triangle sum theorem. And in words, what it says is that the sum of the measures of the angles of a triangle is 180 degrees. 180 degrees. So we're going to draw a picture of a triangle, and let's just label the inside angles 1, 2, and 3 to make it easy. And all this means is that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. That's it, but super important fact to know. So that's the triangle sum theorem. The next one is called the exterior angle theorem. Exterior angle theorem. And I think I'm going to have us draw a picture to go with that first. I think it might make it easier to understand. So let's go ahead and draw a triangle, but what I want to do is show you that each triangle has what's called an exterior angle. So the angles on the inside of a triangle are called the interior angles, and every interior angle has a corresponding exterior one. So let's say I wanted to label my exterior angle here 2, and then the 2 ones on the inside furthest away from that, we're going to label the exterior angle 1, and then the 2 on the inside furthest away from that we will label 2 and 3. So angles 1, 2, and 3, but 1 is an exterior angle, and then 2 and 3 are what's called the remote interior angles. So let's actually write that down. Remote interior angles. So remote means far away. They're far away from angle 1 and they're on the inside. So there's actually something really cool that happens with these 3 angles. If we were in class, I actually have a worksheet where you guys would use protractors and measure the angles and come to this conclusion yourself. But we're trying to streamline things with the online learning, which I'm just going to tell you the answer. And that is that the measure of angle 1 is going to equal the measure of angle 2 plus the measure of angle 3. The words that we would use to say that is the measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. So that would be the words for it. But as long as you have the picture, you should be fine. Okay, our next theorem is acute angles of a right triangle. Acute angles of a right triangle. This is kind of a fact that you can figure out without actually hearing about the theorem, but it just means that if you have a right triangle, and we know that all 3 angles have to add up to 180, we have one angle here is our right angle, which is 90 degrees, and then we have 2 more acute angles, angles that are less than 90. Can anyone tell me what the sum of the 2 acute angles would have to be? They add up to 90. So the measure of angle 1 plus the measure of angle 2 would be 90, since the total has to be 180. and we already have 90 degrees taken up with a right angle. The fancy math name for that is to say that angle 1 and angle 2 are complementary. Then we have one final theorem before we just do a couple examples. The last theorem is angles in an obtuse triangle. Angles in an obtuse triangle. And the words say there can be at most one obtuse angle in a triangle. So let's just draw an obtuse triangle. There's one obtuse angle at most. Does anybody know why there can't be two obtuse angles in a triangle? Why can there not be two obtuse angles? The reason is because obtuse means more than 90, right? And if I had two angles that were more than 90, then when I added those two angles up, just those two angles alone would be more than 180. And I know that the total of all three is always going to be 180. Okay, let's just do a few examples. Example 1, we want to find the measure of x. So let's just draw a triangle. You don't have to worry about it being to scale. Let's make the angles be 5x, 5x, and 8x. What would be an equation that we could set up to solve for x? Let's add them all up and set them equal to 180. So 5x plus 8x plus 5x equals 180. If I combine like terms, 5 plus 5 is 10, plus 8 more is going to be 18x. Then the opposite of multiplying by 18 will be dividing by 18. So x is 10. Now, if the directions said to find the value of x and each angle measure, you would need to plug the 10 back in. So this angle would be 5 times 10, or 50, as with this one. And the last one would be 8 times 10, or 80. So let's go ahead and take a look at a couple more examples here. Let's do an example using what we learned about the exterior angle. So let's call this example number 2. And I'm going to show an exterior angle here of x degrees, and my two remote interiors are 20 and 45. So how can I find the measure of angle x here? Go ahead and read what you learned about the exterior angle theorem and tell me if you would know how you can solve for x. Well, we know that the exterior angle x is the sum of the two remote interiors. So all I have to do to get x is add the two remote interiors up, and I get that x is 65. All right, let's go ahead and do another example here, and this will be our last example. We'll have this be example number 3, and when we have our Zoom session today, then, not today, whenever you do end up watching this video, it could be tomorrow or the next day. When we do our Zoom session on this lesson, we can do a lot more examples together. So example 3 says, and I'll read this slowly. You might want to see if you could figure out how to draw a picture, but I will definitely show you, so don't worry. The measure of one acute angle of a right triangle is 6 more than 3 times the measure of the other acute angle. Find the measure of each acute angle of the right triangle. So the first thing that I would recommend you do is draw a right triangle. If you have a math problem that says there's a right triangle, I would draw the right triangle. Now, it says that the measure of one acute angle is 6 more than 3 times the other. So let's go ahead and mark this one as x. How would I write 6 more than 3 times that? I want to write 3x for 3 times and then plus 6 for 6 more. Now we could add all 3 angles up and set them equal to 180. But if we remember what we just learned a moment ago in the acute angles of a right triangle theorem, we know in a right triangle, 90 of the degrees are already taken up by that right angle, so we only have 90 left for the other two. So the shortest way to solve this is just to add up the two acute angles in the right triangle and set them equal to 90. You can add up all three and set them equal to 180, but if you subtracted 90 from both sides, you would have this same equation. Now when I take x and add it to 3x, I get 4. So 4x plus 6 equals 90. The opposite of adding 6 is subtracting 6. So then 4x is going to equal 84. And then we're going to go ahead and divide by 4 on both sides and get that x is 21. Now the directions on this problem said to find the measure of each acute angle. So we're actually not done. The first angle is just x, so that would indeed equal 21 degrees. Now there's two ways we could find the measure of the second one. Do you know what either of those two ways are? Think about what you know about the two angles. So one way would just be to plug the 21 back in like we normally do, right? 3 times 21 plus 6. 3 times 21 would be 63, plus 6 would give us 69. So one angle is 69 degrees and the other is 21. However, you might have seen the shortcut. We know that the two angles add up to 90. So once we know that one of them is 21, we could just subtract 21 from 90 and get 69 that way. Either way, we're going to get the same answer. So I hope this helps you. This is our notes for 5.1b. Thanks so much, guys. Bye.